looking over problem 2, what's the point here? What is the professor trying to do? Well, he's going to give us a very simple problem to deal with. Once again, just recognizing and using antiderivatives that we can pick up right off the top of our heads, applying, in this case, the power rule. But he's testing your ability to do a definite integral where we can plug in these endpoints and come up with an area under the curve. So what I was going to do is I always rewrite these kinds of problems. There we go. Rewrite these kinds of problems to make the exponent, in this case, 1/2. I find this a easier way to do it. So let's just do this integration, and 2 becomes 2z plus, now we use the power rule, so we add 1 to 1/2, and so we get z to the 3/2 divided by 3/2, just the power rule, plus a constant here, but of course we're not doing that. What we're doing is evaluate it between 1 and 9. Take a look at this. We're going to get, this actually changes a little. I might rewrite this. 2z plus, now this becomes the reciprocal when we move it up, so we get 2/3 times z to the 3/2. And now this is equal to, evaluate it between 1 and 9, is equal to, plug in the 9, we get 18, 2 times 9, plus 2/3 times 9 raised to the 3/2 power. Basically on your calculator, take 3 and cube it, and then take the square root. And there's our first part where we plugged in 9, minus our second part where we plug in 1. We get 2 times 1, which is 2, plus 2/3 z to the 3/2. Well, 1 raised to the 3/2 is just 1, so we get something like this. Multiply these things out, and we'll get 18 plus 18 minus 2 and 2/3. This is now 36 minus 2 and 2/3, which might be considered an answer, or you can convert this to thirds. Basically multiply top and the bottom of 36 by 3, and you get 108 thirds minus, and this becomes 8 thirds, equals 100 thirds. But whether this would be considered a complete answer or this, I don't know how they're going to be grading that test. But there you go, definite integral.